A key characteristic of intelligent behavior is the ability to have and pursue goals. For that reason, we are thinking about what kind of goals could an artificially made system have. And as one of the main problems of AI safety, we have to figure out where do goals come from. And as we move forward, you might realize that the question of where do goals come from is essentially the alignment problem, and it expands into if we don't know where goals come from, we would not be able to understand how they specifically emerge under certain environmental conditions in within certain contexts of interaction among different artificially intelligent agents. And what we'll try to cover in this video is exactly this problem of what is it about goals that makes them so central to the alignment problem and to intelligent behavior more broadly. And so the first question we ask, and you may be wondering about, is whether AI systems can have their own goals. And by now, it should feel a natural answer to say that, well, since we have no ability to directly encode or hard code any values or goals into deep learning systems, of course, AIs would be able to find their own goals, since goals are learned, values are learned. And this is where it gets interesting, because exactly we don't really know what an AI system will learn as its goal. And these week's papers are both concerned with this idea of goals that emerge as instrumental goals, terminal goals that seem to be kind of arbitrary. The developer wants the model to do a certain thing, but as the model is trying to achieve that goal, it finds some other goals. So this distinction between final and instrumental values and goals. And of course, the recurring worry that there's no technique to reliably install any values or goals into a system, and the meta-ethical question concerning the kinds of values we would want collectively or individually for a system to learn. So this is the first paper by Peterson called Machines Learning Values. The second paper of this week is a classic in AI called The Basic AI Drives by Stephen Omohundro. In this paper, you may think that it is closer to the current contemporary AI work. However, you'll realize that it's referring to any system, any sufficiently advanced system. So the paper is architecture agnostic in that sense. We're not trying to push for the current deep learning systems. Any system will have a set of drives, and Omohundro calls them drives because they appear by default. They appear kind of naturally on their own, if you may call it naturally. And so if the developer would like them not to appear, they'll have to do something explicitly against their emergence. So this is the very quick summary of what these two papers are about. And of course, the Basic AI Drives explains in more detail what these drives are and why they're important for understanding the difficulty of installing complex human values, which connects to the first paper by Peterson. So it's important to read those papers together for broader context and for making the arguments even clearer, but of course they are standalone papers making very helpful arguments and giving you necessary context for understanding the alignment problem better. So the important question that I feel like we have to be thinking about very hard, and just to be completely transparent, we do not have the answer. We do not know where goals come from. And if we did, and when we do, we will be partially or to a high degree resolving the alignment problem. We will know what is it that makes certain goals be what they are, appear as they appear, and we may even have some control if we understand the process. But as of now, this is very much an open research question. So please do not assume, just because this is part of a series of papers or of coursework, do not assume that this is resolved. There is a lot to think about here. So this distinction that you'll see between terminal and instrumental values or goals, terminal goals are the kinds of goals that are arbitrarily given. They're given by a developer. For some reason, the system has a very specific terminal goal. And in order to accomplish that goal, it develops instrumentally convergent goals. As you'll see this term, instrumental convergence. And these goals facilitate reaching the terminal goals. In other words, these are some milestones on the way to accomplishing your final results. And of course, intelligent systems feature both kinds of goals. They tend to have a terminal goal towards their always moving, and they also have all sorts of other goals that appear for making that terminal goal happen. So you'll see both. And in some cases, it might be difficult to distinguish between the two. We might not be able to know for sure what kind of goal the system is pursuing at any given moment. Now, what Omohundro talks about in the paper is a series of AI drives or goals, which, as you go through them, and as you'll see in the paper, have this instrumental nature. In other words, they make it easier for the intelligent system to get to its final goal. And these should feel intuitive because any intelligent system, humans included, feature these kind of drives or instrumental goals. And if we'd like to go through them, it will make sense to want to self-improve. An intelligent system would need to make itself better to get more of what it wants. It will be a rational decision maker. Try to get a lot of what you want. Optimize, as we say. Optimize for what you want. Find a way to reach the result efficiently. Don't lose a lot of value on the way. Make sure your goals remain intact. Preserve your goals. Don't let anyone alter your utility function, as we say. Prevent counterfeit utility. Make sure you desire things of true value. Have the means to determine what is really bringing value to you. And Omohundro gives an example of some desires, some goals might end up in wasting one's life. So the agent needs to know what the difference between those would be. Make sure you can protect yourself. Don't anyone change you or cause any damage to you, because otherwise you wouldn't be able to pursue the goal of yours. And finally, make sure you can acquire the necessary resources. Make sure that you have what you need, and you will have what you need as you move forward, because otherwise, how are you going to achieve your goals? So I hope these make sense as instrumentally convergent. And the claim here is that any intelligent system will feature these instrumentally convergent goals. And this could be dangerous, as you'll see, Omohundro argues for. And it could be a problem for the developer, and it could be hard to detect at what stage the model is exactly, because it's also incentivized not to reveal, it's part of this description for the model not to reveal all the things that it's doing towards achieving its goal. It's sort of part of this self-protection. Don't let anyone change you. Don't let anyone modify your utility function in a way that you would not be able to further your mission. So the implications of these AI drives are widely discussed in the field of AI safety, and they do motivate discussions about the nature of agentic behavior, which is exactly the kind of the behavior, the system that is autonomous and could pursue general intelligence tasks, such as those that the AI companies want to have made. So I hope this discussion was helpful in thinking a little bit harder about what it means for a system to have a goal. You saw this is a way a system can feature a goal that arises sort of towards another goal, the instrumentally convergent goals. And then for the rest of it, it's very much an open-ended question. Why would a model have any final goals? How do these goals appear? And part of the alignment problem is that we would like to be able to tell the model what these goals or values are, and preferably these would be aligned with humanity at large, and they would lead to flourishing futures for everyone involved. But we don't really know how that could happen. And you also see that the difficulties that arise in all these other goals may make the problem even more complicated. So I do highly recommend that you go to the Basic AI Drives paper that you will find hyperlinked in the syllabus, and you read that. It's not very long, but it will give you all the explanations with more examples of what each of the drives entails. So you'll see in more detail than what I described here what all these AI drives are. And again, it's a short paper, so that should be easy to cover now, especially with the context that I've given you. And the Pearson paper, Machine Learning Values, where you'll get to read more about why values are complex, what does value learning entail exactly, and why is this so complicated, and some directions for navigating this problem.